Good morning, students. In today's video, we are going to cover the two topics, that is principle of buoyancy, yeah, and of course density. So let's start here. What is buoyancy? So buoyancy is the upward force that a fluid, or water or air, applies on any object placed in it. So basically it is the upward force. Suppose you put this box inside the water, so the water um, exerts a force on this particular object and in upward direction. So this is the buoyant force. Why does this upward force happen? Pressure at the bottom of the object is greater than the pressure at the top. This pressure difference pushes the object upward. So when you place this, you can say, box inside the water, so the water exerts pressure on it from below, and the upward water means the water over the surface also exerts pressure, but this particular force is more than the upward means this force, so that's why the object moves upward. Okay. Name of this upward force. So what is the name of this force? The buoyant force. Buoyant force. Archimedes principle. So yesterday we have covered Archimedes principle, but now let's see the exact definition. The buoyant force on a submerged object is equals to the weight of the fluid displaced by the object. So this beyond boy beyond force excuse me for that if I pronounce it wrong. So this buoyant force, so this buoyant force uh, this upward force is equal to, so the magnitude of this particular buoyant force is equal to, scientists have discovered that is the magnitude of this buoyant force is equal to the weight of the fluid displaced by the object. So this object, if you put it into the uh, into the water, so it takes space of the water, you know. If you remove this object, the space covered by it will fill with water. So that water that covers this object space, when we take out this object, that is the displaced fluid. Okay, so this the magnitude of this upward force, or we can say buoyant force, is equal to the uh, weight of the fluid displaced by the object. Now let's see what buoyancy does. Helps object float, reduces the effective weight of objects underwater. So what buoyancy does is it helps to, of course, it's pushes the object upward, so it helps the object to float, and it reduces the effective weight of objects underwater. So what does this effective weight means? That it is also called, you can also call it as felt weight. It is more easy to comprehend. So what happens in this is that if you take a stone and if you uh, hold it in your hand in air, it will feel very heavy, but that same stone, if you put it under the water, it will feel little lighter. Okay, and that is called the felt weight, or you can say the effective weight. Okay, now comes the question. Now the next topic is what is density. So the density is how much mass is packed in a given volume. So if you take this box, this means this particular space, so this particular space is the volume. This particular space is the volume, and the particles, suppose it is a solid, so the atoms are close to each other. Okay, so this this is called now the density. Okay, the space that this object covers, this solid object covers, is called the volume, the space. And then we covered this space with a solid object, and that solid object's mass is called the density. So density is how much mass is packed in this volume or this space. Okay, how much mass is packed in this volume, or we can say this space. Okay, so if it has high density, heavy for its size, and if it has low density, light for its size. So of course, means high density means more mass in this particular volume or space, and low density meaning less mass in this particular space. Okay, density and buoyancy are connected. Whether an object floats or sinks depends on its density compared to the fluid. So if an object floats or sinks, it depends on the density. Okay, whether that object will float on the water or it will sink. There are three cases uh, related to it. The case number one is object floats. Object floats in the first case. So what happens to an object in the water, we can say. These three cases mainly arise, so let's look at these. First is the object floats. So the object density less than the fluid density. So in this, the object density less than the fluid density. So that means the buoyant force is greater than its weight, of course. So because of that, object force means that upward force, buoyant force, is more than the object's weight. And this weight is, if you know, that weight is also an force. So force this weight exerts a force, and this is the buoyant force. So this buoyant force is greater than this one, so because of that, object flows. And we can also see in that way, in the density way, is that this is the buoyant force way. Okay, in the density way, we can say that the object's density is less than the fluid density, and because of that, the object floats. So there are two ways to see this particular situation. Firstly, in the form of density, and second, in the form of buoyant force, or we can say forces. Object neither sinks or nor floats, so the object density is equal to the fluid density, and the buoyant force is equal to weight, and object stays at same level. So here the object density is equal to the fluid density. Okay, and because of that, and also the buoyant force is equals to weight, so object stays at the same level. It neither floats on the water nor it sinks down. It just stays at its place. And lastly, object sinks, so the object density is greater than the fluid density, and weight is more than the buoyant force, and because of that, it sinks down, or we can say it goes down. Okay, so these are mainly the three cases that arises, and we have seen both the density way and the forces way. Forces density, of course we see the object's density and fluid density, and based on that we make conclusions about whether the object will float or sink. And similarly in the forces way, like the beyond force and the weight is also a force. So based on that we made conclusions that whether an object will float or sink. And here is an extra example. um, a ship floats even though steel is denser than water. So this question is pretty valid, and it arises in everyone's mind that why the ship floats even though it is made up of steel and it's very heavy. Still it floats on the water. So the reason behind is that the ship has air inside of it, and this makes the average density of ship less than the water. Okay, so ship, we know that the whole means ship is not wholly made up of steel. Okay, it is not the case. There are some rooms and like storage space etc in the ship. So because of that, air fill inside of those spaces and makes the whole density of the ship less than the water. And because of that the water floats on because of that the ship floats on water. So I hope this example is clear to you all. And today's homework is to make an image in your mind explaining this concept. So that's it for this video. Thanks for watching.